Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, Palindrome Linked List. So here we are on going with this question and with this. So in this question we are given the head of a single linked list, return true if it is a palindrome. So basically a linked list given and we are required to check that in that linked list is it a palindrome or not. We all know that what is a palindrome. It is simply that when we move till the middle and then when we move from middle to next half of that particular linked list or array, whatever is given to us, then they should be equal. Basically what I want to say is, okay, 1, 2, 2, 1. So here middle is this, right? So both of them are basically equal. If we see from this side, then 1, 2 is there. If we see from this side, then 1, 2 is there till middle. And that's how it makes a palindrome. Any other if we see like 2, 3, 1, 1, 3, 2, or let us take some random number 7, 8, 5, and 5, 7, 9. You will pretty much see that all of these are palindromes. These are for the even numbers. What about the odd numbers? For odd numbers also, it is somehow same. Means it will check till here, it will check till here. Means here it can see 1, here it can see 1, and in the middle, only one number, that is 2. So this is how what a palindrome is. Now comes the next part. Let us check for constraints. So as it is a linked list, 2, 10 is per 5. So order of n solution would work. If we go ahead with n square, then it would give us daily. So here n square n solution is the one which would work. The node value is basically single digit that they want to indicate, and even there is nothing related to negative. It's all positive. And they have given us the follow that could we come up with order of 1 space or not. So now let us start. That's how we can go ahead with the same. So the thing is how we had solved the palindrome questions earlier. Earlier it was an array, right? Or even it was a particular string or it was a number, right? So now just recall back how you used to solve an array. In arrays you usually use 2 pointers, right? Means array was given to you and you used 2 pointer. One pointer was from this side, other pointer was from this side, and you were easily able to figure out that is it a palindrome or not. Just by checking that is it equal? Yes, then we move ahead. Is it equal? Yes, then we move ahead. Is it equal? If by chance it is not equal, then we completely get out from this particular, else we will be checking for the next one. So this is how you used to do in array. So in this solution also, what we can do is we can copy all the nodes which are being given in this particular linked list to an array, but that would be using order of n space. Here the thing is, but we are today now trying to do with the follow-up question also. So that's why first I'm just explaining you. So what we can do is that we can directly copy all the nodes of this particular to the array, and then we can do this particular thing only which we used to do in the array. So this was about the naive approach, where the time complexity remains the order of n, but the space complexity also becomes order of n. So let us move to an approach where space complexity is optimized to order of 1. So let me show you for the same. So here it is. So here we come. This is the example which is being given to us, and we will be returning to because it is a palindrome. Nice solution which I was letting you know was this one. And this is the optimized one. Where at the first, these are the steps which we will be doing for making a solution optimized using order of 1 extra space only. So first thing is as we are required to check for a palindrome, so palindrome is always indicated by a middle element which is being there. If from the middle element, the other half, we reverse it, right? And then we start comparing with the last element which was there as it was reversed to first element. Then if we compare both of the half of linked list with the first element, then second element, then third element, if they are equal, then surely it is a linked list. If they are not, then it is not a palindrome. Although linked list is already there, but it is a palindrome, then they are equal. That's I want to say. So let us move that how we would be going ahead with the same. So first things comes up is base case would be this one only because it is a linked list, and here the thing is that I would be using recursive solution, so that's why base case is there. But also in iterative solution too, the thing is this will be acting as an edge case because if root is null, so we would be obliged to return true, and if it is not null, so we would be going ahead with the same. So for reaching the middle, how we would be doing is, for this also, basically this question is combination of two questions. One is reaching the middle and the other one is reversing the linked list. So if you want to get ahead with more detailed video for the same, you can check out. I have already made as in one of the Leetcode daily challenges, these questions were already there. But I know by you, if you are already clear with the concepts, then it's alright. I'll explain here only. So I'm explaining here also the diagrams. So when we want to reach the middle, so here we would be using 2 pointers, and how those 2 pointers would be working, that one pointer and the second pointer, basically we would be using slow and fast pointer, naming it so that you could easily recognize that how this is working. So slow pointer would be moving just one pointer ahead, means basically just one node ahead it will be moving, but the fast pointer will be moving 2 nodes ahead. So that's the thing it will be ongoing with, but we will be making a solution in such a manner that we are easily able to come up with the middle. See, slow would be moving one node ahead, right? So slow would be first going to this one, but the fast will go 2 nodes ahead, right? Then fast simply goes to 2 nodes ahead at this position. Then at this point, slow would be at this particular point. And when fast reaches at this particular point, right? So then slow would be reaching to the middle. So this is the criteria that when fast would be able to reach just the end of the linked list, or if it is pointing towards the end of the linked list, right? Because after this it will be pointing to null, right? So that's why at that particular point only we would be exiting out from the loop, right? But the slow pointer itself would be pointing towards the middle, and at that point only when we exit, the slow would be having the value of the middle, and thus we are able to reach for the middle node, and that is the thing which we would be passing to our reverse linked list function. So when we go ahead, here I have just changed the example, means example is only this one. Now let us consider the whole of this example, because it was becoming difficult for me to explain with such a small linked list. So that's why I just taken, let's just consider it that this is the whole example, means this one. So here this would be the second half, right? So that's the thing which I have taken here. Now in this criteria, how I would be reversing is, rather than using the iterative approach, I would be reversing with the recursive approach. So here first this particular would be passed, and then it will go till the end until it reaches the null. So here when it is at the null, so one would become head. So let us go one step ahead at this point when this particular is there and this particular is there. Means basically head is basically at this point, that is no. Oh, 1 minute. Let us take head to be 2 only. Yeah. So what I have done is I have taken that rest tail equals to heads next. So our heads next was basically null, right? So that point would be already handled. So that's why I was taking for this particular point. So let us take 2 as the head. So our 1 minute. Means if whatever would be head here, let us start with the last one only. So let us take this one as the head, right? So rest tail is basically heads next. So here heads next is if one is the head, right? So heads next would be null at this particular point. Let us not consider this. And that heads next would be the present head which is there, that is the one. So here that rest tails next was basically R1. So that's what we were considering. Let me first just take this one. See, the thing was that here rest tail was basically heads next. That was the thing which we were capturing here. So our heads next is basically 2. Not 2. Here it is already 1. If 2 we are considering as heads next, right? So this particular is for this 3, this particular point. That if 2 is there, then 2 next is basically 2 itself, right? So now rest tail next that we want, so that we will be taking our head itself. So here our head would be this particular 2 only. I guess I have taken it wrong. Please, I'll explain you again. Rather than explaining it wrong way. Let me first explain it, then we will move ahead with the film. So here the thing is that particular rest tail next that we wanted to figure out, right? But before that, we were going ahead with the head next, right? So our head would be pointing towards this particular one. If we take this 2, let us take from this middle itself. So the first thing which we means when we reach this null, if we start from the null itself, right? So at this particular point, our head is equals to 1. Our rest tail at this particular point would be equals to heads next, and our heads next is basically null, right? So that would be our head tail at this particular point. For rest tail next, that is our nulls next would be at this particular point pointing towards the 1, that is which is the head here, and then our head which is our 1, right? So we will be making its next as the null. That is, we are basically just disjointing it from the whole linked list. That's what we are doing. And then we would be returning a rest head. Basically, all this would be stored in one more other, because we are here back. These steps are basically at the backtracking step, so that when at that particular point, because at this particular point when our pointer is there and it is returning from our end point, so at that moment only it will be returning to this particular, and here it is pointing towards the rest head. So all this would be returned to our rest head. Means this value would be basically in our rest head, and we are taking this rest head and rest tail as 2 pointers, which will be one would be storing the head of the linked list and other would be storing the tail of the linked list, and it will help us in reversing the whole linked list. That is the thing which we are using here. And this also old question I have explained in another video. You could check it with for more information about the recursive tree and so on. But I just tried to give the overview only. But one thing is also there, that we need, because we shouldn't access the null pointers, that is this particular shouldn't become a head. So for that particular thing only, we have taken the base cases that if our present node, whatever node is there, if its next is equals to null, that is it is not there, or the node itself equals to null, then at that particular moment only we will return. So basically this won't be exist. That's why I was taking example of this one. But here, just for explanation sake, I've given that how the things would be changed. But the thing is that this won't happen, means this null would never become a head, because when our 2 would be head, that at that moment only our 1 would be processed. So this is the thing in this particular reversing process. Now comes the part for our palindrome. So for checking the palindrome, as we were checking in array, how we were checking? We were taking 2 pointers, right? But here now we are already having a 2 linked list. One is for the reverse one and other one is for the current one. So we will be checking the value at first value at the reverse linked list and the second value at the current linked list. If both of them are not equal, then we will be returning false. And one more thing is this whole process would be done in a loop, so that we are able to check for the whole linked list. So for that process only, we will be taking any half of the linked list as the condition for exiting our loop. And what does that mean is that until our reverse exists or until our current exists, so that would be the condition for a while loop. And the next step would be inside our while loop is that we will be changing for the next node of both of the linked list, because we need to check for the next nodes also. And at the end, when this particular loop ends, then as earlier false was not returned, right? At this condition also loop would have exited, but it doesn't exited at this point. So that's why, thus we are required to return true it after the end of the loop. So this was all for this particular question, and it is already order of 1, space complexity and order of n, time complexity, although recursive stack is there for that particular recursive way of reversing the linked list. But if we avoid that recursive stack, because we can also use the other way around for reversing the linked list, that is iterative manner, in which our recursive stack won't be used. So in that particular criteria, it will completely become order of 1 space complexity linked list. So let me walk you through the code, because now the explanation is done. So here is the coding part. So in this particular, first this is our main function. Now for reaching the middle, we are using this particular function. The way I had explained that fast next and fast next would be, if any one of them point towards the null, then at that point only it will exit the loop. This is for taking into the consideration when our linked list is even numbered or odd numbered. Basically here I am saying about the size. So for that particular purpose only, we are taking both of the conditions. That if any of one, not any one, when both of them becomes true, then at that point of time we will exit out the loop, and we'll our slow would be just moving 1 point ahead and our fast would be moving 2 points ahead. And when this particular loop gets exited, then we will be getting our value. So here I was just checking that what exact value we would get. So before that, we are required to reverse our linked list, and here now we would be reversing our linked list by passing the slows next. Because I had already, when I was explaining here, you can directly see that when this particular node, this fast reaches at this point, so it's fast next is not although null at this point, but fast next is null, right? So when any of the one conditions become true in AND condition, right? So it will directly exit out at that particular point only. But 0 and 1, okay, yeah. So at that point it won't exit out, but as one of the condition here, so as both of the conditions were becoming here true, right? So here fast next is this and fast next is this, right? But still it is pointing to a node, right? So still it is not true. But when it moves to the next point, that is at this particular point itself. So at this point, fast next is already null, but fast next that would be already null, right? So that's why it will exit out the loop. So at that particular moment, our slope will be reaching towards this particular point. So that's why we are passing it like this. We are directly passing the flows next, because at any point the thing would be that there would means in this particular linked list also, when, because it is even, right? So when 2 is at this particular point, so we would be passing its next at this particular linked list. So that's what it want to indicate. And when it is about this particular, right? So when it will reach at this particular point, so it will be passing this particular only, means including this one and this. That's the thing which we are doing here. So now next comes the part that how we are going to reverse it. So that reversing is done here. This condition which is being handled the way earlier I was saying, that at that moment only it will be returning the head at that particular point. So when we reach at this one, so its head is not null but head next is null, right? So here head would be returned as it is to this 2. So that's why it will come up here. I was getting like I was unable to explain what I had written at that point. So yeah, here also I can explain now. So then a link list note rest hat, where we are basically handling for the head. So at this particular point only, now we will be directly moving ahead with means, as we will be starting from this particular point, because our head would be here, right? Just consider that this is the second half. So for that purpose only I'm saying. So it will go till end and end. And when it reaches at this point, it will return this particular to this particular, right? So when it reaches this point, then at rest head would be returning head to the same, right? But now comes the next call which was there left at this particular point, and the backtracking step. So at that backtracking step, this reversing of linked list will take place. This rest tail will help us to reverse the linked list by taking the head next into the same and then making the rest tails next equals to the head. So at this point only it will reverse, because 1 and 2 when there are, and this is head and this is head next. So basically rest tail will be storing the head next. Now this is the rest tail, right? And our rest tails next now becomes our head, that is this particular. So that's why now our linked list would be reversed. So that is what is doing. And head next it will be making null. So head next what basically 2, right? So now it will be pointing towards null. So this is what we are doing in this particular. And then we will be returning rest head, because all this particular would be at this particular coil. Although let us take this example only, means 2 and 1. So 2 is here. So all this particular would be doing at this particular only. So this will be returning to its previous caller to this return rest head. And that is what we are doing in this particular reversing linked list point. Now comes the part for palindrome. Here the thing is that we'll take point flag for any particular linked list, and here we are taking for reverse until it becomes null. We will be checking for each node, moving ahead, and then at the end will return true if return false was not at this particular moment of time. So this was all for this particular question. If you have any doubt, you could comment that down. Please do like and subscribe to my channel. Yeah, so this was all for today. Thank you.